Hello and welcome to the 4-3 Notes. In this section of notes, we'll talk about periods changing in sine and cosine graphs. So an example of period changing, or just period. If I have a sine graph, it'll look something like this. Like I said yesterday, it goes on forever. And the period is where it stops doing something new and it starts repeating. So for example, if this would cooperate, there we go. That would be one period of this graph. Because after this green box ends, it starts doing the same thing that it did at the beginning. So it starts repeating. So that's one period. What we want to do on these ones, and a recap of you go back to the previous day's notes here, the general form is up here in purple. I'm going to use purple again to write that. So y is equal to a, and we'll just use sine as an example, of b times x minus c plus d. So again, what we were talking about up here, this is the vertical shift, horizontal shift, amplitude. The b we did not mention yesterday. What the b does, that's what changes our period. So normally, well, in a generic graph, our period is 2 pi. When we have a different b value besides 1, or if it is 1, we also would divide 2 pi by b. And that's how we get a different period. So in example 1 here, we're going to be graphing this. I know our amplitude is going to be 1. Our period is going to be 2 pi divided by 2, because our b value is 2. So our period is pi. That makes our quarter sections, so that's what Q stands for. Our quarter sections are our period divided by 4. What that means is just our quarters are just, our entire period is divided into quarters, which is 4. So that's why I'm dividing by 4 there. And then our shift, we don't have any. So now, because our amplitude is 1, and there's no shift, I'm just going to have 1 and negative 1. And then our x-axis is going to be the period divided by 4, so each of these is going to be pi over 4. I'll just say 2 pi over 4, which I could reduce. This would be 4 pi over 4, which I could reduce. So I'm just going to erase those. So I just wanted to write out the original, like 2 pi over 4 and 4 pi over 4, just to show you how I'm getting these. So I know it's probably annoying that you had to erase things if you wrote them. So I do apologize for that. But anyway, here's our midline. And we're graphing cosine with an amplitude of 1. So cosine starts at 0, 1. Every time we move right, however much our quarter section is, in this case pi over 4, I go down our amplitude. Do it again. Then I start going up, and then up. So cosine, I like to graph the inside first. And when I graph the outside, it kind of goes out a little bit horizontally at the end. because again, it's going to curve. So that's kind of the start of the curve there. So we have kind of a zoomed in graph here. Our period is a little bit shorter. If we were using the same exact x values as this graph, this one would look a lot shorter because the period is smaller. In the next one, we're still going to label all the same things. This one we have an amplitude of 3, and then our b value is 1/3. So for our period, or our amplitude, it's going to be 1. Period is 2 pi over 1/3. If I divide 2 pi by 1/3, it's like saying 2 pi times 3 over 1. Sorry, there's not a lot of room here. So I get 6 pi. So our period is 6 pi, which makes our quarter sections 6 pi over 4, which reduces to 3 pi over 2. And then finally the shift. There's no shift. And I just realized I put 1 for the amplitude. Amplitude, I said, was 3. But I wrote 1. So I'm going to need a -3. I'm going to need a 3. All right, so now our quarter sections are 3 pi over 2. So every time I move to the right from 0, I'm going up 3 pi over 2. So this will be 3 pi over 2. 3 pi over 2 plus 3 pi over 2 is 6 pi over 2, which is just 3 pi. 6 pi over 2 plus 3 pi over 2 is 9 pi over 2. 9 pi over 2 plus 3 pi over 2 is 12 pi over 2, which is 6 pi, which is our period. So that was good that I ended up getting to 6 pi. Bid line is going to be on the x-axis again. For sine, we start at 0, 0, unless it's shifted. This is not shifted, so I'm still going to start at 0, 0. Usually we would go up the amplitude, but because of that negative, that just means we go down the amplitude. Then I go back up, and up again, and then back down. So here's my little curve. That was not good. So something like that. That's not a perfect graph, but good enough. So there's one period. This one is stretched out a lot more. So this one would be bigger on an actual graph. Not only is the amplitude 3, but the period is 6 pi, so it's a lot wider than a normal graph. Now on the next one, we are shifting down 1. Amplitude's 3. B value is pi over 4. So let's see what this one would look like. I know we're shifting down 1, and the amplitude's 3. So for sine, I'm going to start here, and then I'm going to have to go down to -4. I'm going to have to go up to 2. So amplitude is 3. Period is 2 pi divided by pi over 4. So that's like saying 2 pi times 4 over pi. 2 times 4 is 8. Pi divided by pi is 1. So our period is 8. So no pi in our period. Quarter sections, we take our period, divide by 4. So our quarter sections are going to be 2. So this time, no pi in our quarter sections. And then our shift is down 1. So our midline we know is going to be at -1 because it got shifted down 1. And then if I was graphing this at sine, or the graph of sine, I usually start at 0, 0, but because it's shifted down 1, I'm going to start there at 0, -1. Now I'm going to move up. Our amplitude's 3, so I'm going up 3. But before I do that, I need to make our horizontal, our x-axis. Whoops. Our quarter sections are 2, so I'm going up by 2 every time until we get to our full period. So as I move right 2, I have to go up 3. As I move right 2, this time I go down 3. Down 3 again. And then back up to the midline. So the graph of sine for this one would look something like this. So nothing really changed in the way I graphed this. We just didn't have a pi in the period, which happens sometimes, and that's okay. Sometimes you'll see restrictions placed. So sometimes the restrictions will make you graph more than one period. So we'll see what this one looks like, or these two. So we are going to have an amplitude of 1, a period of 2 pi over 1/2. So x over 2, that's the same as saying 1/2 times x. So that's why I'm getting 1/2 there. If I'm dividing by 1/2, that's like multiplying by 2. So I would get 4 pi. So our period is 4 pi. Quarter sections, 4 pi over 4, which is pi. And then shift, we're getting shifted up 3. That plus 3 is not inside parentheses with x. So it is up and down shift. So amplitude is 1, so I don't have to worry about that, but I do need to go up to 3. And then down to -3. Quarter sections are pi, so pi, 2 pi, 3 pi, 4 pi, which is what our period is. Midline is going to be on the x-axis. So normally I would start cosine at 0, 1, but because our amplitude is 3, I want to go up to 3, but this is a negative, so that means I'm going to start down below here at 0, -3. So this negative a value just means my graph is flipped from what it normally is. So as I move right, I have to go the amplitude distance, so this time up 3, and I would go up 3 again, and then down 3 back to the midline, and then finally down 3 again to get back to the minimum. So remember, cosine kind of curves there at the end. So that's not perfect, but good enough. Oh, but I didn't even pay attention to the restrictions. So I have to go to pi over to -pi over 2. and then to just 3 pi over 2. So that would have been our graph if we had no restrictions and we're just graphing one period. To get to 3 pi over 2, that would be right in here. So I still have a point at 0, -3. To get to the midline, I would have to go up 3 and also left pi, but I'm only going left pi over 2. So we'd end somewhere around here. I can go up to pi on this side, but to get back up to 3, I would have to go all the way to 2 pi, but I'm only going halfway there, so that would be somewhere around there. So that graph would look something like that with the restrictions that were placed. So I think it was helpful to see the entire graph and then see how the restrictions affected it. All right, next one, or last one. Amplitude is 1. Period, 2 pi over pi, which is 2. Quarter sections, period divided by 4, so that'd be 1/2. And then shift, no shift. So amplitude is 1, so and no shift, so I go up to 1, down to -1. Quarter sections are 1/2. I need to go from -2 to 4. So I'm going to call this -1, -2, 1, 2, 3, 4, just because that's how far I need to go. But then the quarter sections are 1/2. So I'm going to make these little mini parts, and those mini parts are the quarter sections. So that's how far right or left I need to move in order to go up the amplitude. Our midline is going to be on the x-axis. So sine starts at 0, 0. To go up the entire amplitude, I need to go right the quarter length, which is 1/2. Then I go back down, down, back up. So that shows us we have a period of 2. But we need to keep going because our restriction says go from -2 to 4. So then I would go up, down, down, up. And there we ended at our restriction. On the left side, I need to go to -2. So I would be going down, up, up, down. So our sine graph, and the reason it's so squished together is because our period is smaller than normal. Our period is only 2 instead of 2 pi. So 2 pi is kind of around 6, 6.3 or so. So that's how we do restrictions. Like I said, sometimes it'll be shorter than a full period. Sometimes it'll be more. And that's going to be it for the notes.